Hi, welcome to another session of Ebenezer Gate coaching classes. This is a problem that appeared in Gate 2021. It's a multiple choice question for 2 marks. The impedance matching network shown in the figure is to match a lossless line having characteristic impedance Z0 equals T ohm with a load impedance ZL. A quarter wave line having a characteristic impedance Z1 equals 75 ohm is connected to the load ZL. Two stubs having characteristic impedance of 75 ohm each are connected to this quarter wave line. One is a short circuit stub of length 0.25 lambda connected across PQ, and the other one is an open circuit stub of length 0.5 lambda connected across RS. The impedance matching is achieved when the real part of ZL is dash. Now, the actual original transmission line has Z0 equal to 75 ohm. Now we have, the original transmission line has Z0 equals to 50 ohm. So now the load of that transmission line should be 50 ohm for the impedance to match, so that there is no reflection. Now there are two stubs here, one at PQ, the other one is at RS. The stub at PQ is a short circuit stub, and we know that if the load is zero, that is for a short circuit stub, and if the length of the stub is lambda by 4, which is 0.25 here, lambda, then input impedance is given by Z0 squared by 7. So for a short circuit stub, the input impedance for a length of lambda by 4 will be equal to infinity, or it is equivalent to an open circuit, or this we can ignore the short circuit stub because it is equivalent to an open circuit. Now we have another stub at RS, which is an open circuit stub, and the length is lambda by 2. And we know that if the length is lambda by 2, if the length is lambda by 2, then the input impedance is same as the load impedance. So for an open circuit stub for length lambda by 2, the input impedance is again, in this case also, infinity. So it is also an open, so we can ignore it. So both the stuff we can ignore. So effectively we have only a transmission line of characteristic impedance Z1 equal to 75 ohm and the load ZL. And we are asked to match this with the original transmission line, which is having a characteristic impedance of 50 ohm. So the load should be transformed to 50. So since the characteristic impedance is 50, we need the load also to be 50 at PQ. So we have again the length PR is 0.25 lambda or lambda by 4. The characteristic impedance of that portion is Z1 is 75 ohm. So the input impedance at PQ, Zn at PQ is characteristic impedance squared, that is Z1 squared by ZL. We are asked to find out what should be ZL. And we know that for the transmission line to match Zin at PQ should be equal to Z0, which is 50. So Z0, which is 50, should be equal to Z1 squared, 75 squared by ZL. So 50 should be equal to Z1 squared by ZL, which is 75 squared by ZL. 75 is 75 into 75 by ZL. So ZL should be 75 times 75 divided by 50. So this can be written as 25 into 3 into 25 into 3 divided by 25 into 2. So this is effectively 25 into 9 by 2. This 25 into 9 is 225 by 2 ohm, which is 112.5 ohm. So the option is A, 112.5. Thank you. God bless you.